Okay, hi guys. Now I'll be moving on to your chapter 6, which is further trigo. So yeah. Okay, so learning objectives for today. By the end of this chapter, you should be able to determine the obtuse angles for trigo. So earlier you learned sorry. Earlier for sine, cosine, and tangent, your angles are 0 to 90 degrees. Right? So today you will learn for obtuse angle where your angles are more than 90 degrees. Okay? So more than 90 but less than 180. And then you will learn to find the area of triangle using a trigo formula. And then you should be able to find the unknown side or angle given these three scenarios. So you're given two sides, one angle, two sides, two angle, one side, and three sides. Okay? So let's get started. So this is where your sine and cosine rule comes in. Okay, so let's get started. Okay, so just a quick recap. Pause the video and at this point and fill out these three blanks. So for sine A, cosine A, tangent A, what are the formulas? Okay, so you should know this by now. Sine is your opposite over hypotenuse. Cosine is your adjacent over hypotenuse. Tangent is your opposite over adjacent. Do you know that tangent is also your uh sine over cosine? Okay. Okay, you should know all these identities by now. Okay, so let's see. So in this case, right, we have one obtuse angle which is more than 90 degrees. So let's see if you're given this in a plane and given that the this point, let's say this point A is given x comma y, then sine A is basically equals to uh this part is equals to x, this equals to y, just for reference. Then this would just be equals to sine A is equals sorry. Then you have to find your hypotenuse as well. Right. Hey. Hey guys, sorry for the disturbance earlier. Your first step is to find uh your hypotenuse, which is OA. So this is basically, if you use Pythagoras theorem, it's just square root of uh OA is the square root of x square plus y square. Okay. You can either use this formula or you can use what you have learned earlier through coordinate geometry. So given that this origin is actually equals to 0 comma 0, you can use your coordinate geometry formula, which is square root of x minus x1 minus 0 square plus y1 minus 0 square. Okay. So this would give you the same formula of x1 square plus y1 square root of it, which is the same as what you have over here. Okay. Okay, so once you have found OA, your sine A is basically your opposite over adjacent. So your sine A is actually equals to your opposite, which is y1 over your hypotenuse, which is OA. Okay? So this is for your acute angles. Then next, the question asks for cos B. So in this case, cos is actually your angle B is an obtuse angle. So how are we going to solve this? So you're actually given a trigo formula. So this one you need to know. I'm going to write in red. your sine A is actually equals to sine 180 minus A. Okay? And your cos A is equals to negative cos 180 minus A. Okay, so these are your trigo identities, and you need to be familiar with this, okay? So if we see your cos B is actually equals to cos cos 180 minus A. Okay? So since we can represent it in this form, it's basically equals to negative cos A. And your cos A is basically equals to x1 over OA. So it is negative x over OA. Okay? So you don't have to know the sides and angles for an obtuse triangle. You can just use this identity to solve the problem. Okay, so now let's practice some question. So again, I want you to pause the video at this moment and try it out yourself before I go through the answer with you. Okay, so now I'll be going through the answer with you. So given that sine, so you're given these two details. Find the value of sine 125 and cos 44. So for your part A, sine 125 is basically sine 180 minus 125 degrees. And 180 minus 125 is actually sine 55. So this is equals to 0.819. And for your part B, cos 136 degrees equals to negative cos 180 minus 136 degrees equals to negative cos 44 degrees. Oh, sorry. The question asks for cos 44. So cos 44 degrees equals to negative cos 180 minus 44, which is equals to negative cos 136 degrees. So minus 0.719. Okay. So we should be able to get this answer without the use of a calculator. So just know that for your quadrant, right? Your y, you have x. So your sine is positive, cos is positive, sine is positive, cos is negative. Okay, so this is always true, okay? For any angles between 0 and 90, your sine and cos is always positive, but your uh for angles from 90 to 180 degrees, your sine is positive, but your cos is negative, okay? Okay, now let's move on. So we'll do some more questions. So the question is asking for sine ACD. So again, this is an obtuse angle. So if you take a look, sine ACD should be equals to sine 180 minus angle ACD. Okay? So sine 180 minus sine angle ACD is sine angle ACB. So sine of this angle is your opposite over hypotenuse, which is 3 over 5. Okay, now your part B, cos ACD. So again, same thing, but it will give you a negative cos angle ACB. So it is negative 4 over 5. And then your part C tangent can uh for tangent, right, you can just do your part A over part B. Okay? So tangent ACD equals to sine ACD over cos ACD. So this is equals to 3 over 5 divided by negative 4 over 5. So if you type this in your calculator, you should get negative 3 over 4. Okay? You can either do that or, okay, let me go back to your quadrant. In this case, your tangent is also positive, but for angles more than 90, your tangent is negative from 90 to 180 degrees. Okay? So if you take a look at this, you can also use the quadrant. So your tangent is your opposite over adjacent. So it should be AB over BC. So tangent equals to opposite over adjacent, negative 3 over 4. Since your angle is more than 90 degrees. Okay. So you should automatically plug in the negative when your angle is more than ABC. Okay, and then uh okay, before we carry on, the question this part is ACD, right? But the question is asking for BAC. BAC is this angle. This angle. So when it's BAC, you should be straightforward. So your opposite is 4, adjacent is 5. So, and this is an acute angle, so it's 4 over 3. Okay? This is just a example of what it would be for obtuse angle. Okay? Alright, so now let's get on. Okay, I want you to pause the video again, try this question yourself. I will go through during your lesson time, okay? Um, okay, now I'll go through this question. Okay, so this question, uh, you're given that your x can be between 180 degrees to 0 degrees, and they are asked to find the possible values of x. Okay, so sine x equals to 0.45. So if you use your calculator, you can have two different values. So your x can actually equals to be sine inverse 0.45, or it can also be equals to 180 degrees minus sine inverse 0.45. So make sure that your angle unit for your calculator is in degrees and not radians. So you should get 26.7 degrees and 153.3 degrees. Okay, so if you don't believe me, right, if you type sine 153.3, you should get 0.45. Similarly, if you type sine 26.7, you should get 0.45. Okay, so that's why for sine, when your angle is between 0 and 180 degrees, you'll get two different values. Okay, now your part B, cosine x is equals to negative 0.834. So since negative, you know that it is a obtuse angle already. Okay, so you can straight away write cosine x is equals to cos inverse 0.834. Sorry, negative 0.834. Then you should get 146.5 degrees. Or you can also use the trigo identities. You can put x is equals to 180 degrees minus cosine 0.834. Do note that over here, this is positive. And you should get the same answer. Okay? So, yeah, these two methods, I'm just manipulating the formula. So, a straightforward method would be this method here. So, yeah, and this one is just another form of the same solving the equation, but a different method, just using some contextual knowledge of the formula. Hmm. Okay, so before we move on, let's take a look at this. Again, do pause the video and try the question, and I will go through in a bit. Okay, so just note that your this chapter combines with your previous chapters, so you do need to know what you have learned earlier. So in this case, this is very similar to coordinate geometry. So the question is asking you to find sine ABC. Okay, can't see. Sine ABC, cos ABC, and tangent ACB. Okay, so I'll mark out the angles first. So first step is to make it. This is the obtuse angle, right? So the acute angle is actually this angle. And then let this be x. So your AX is actually equals to, this point is 2 comma 1. AX is equals to 3 units. Okay? And then how do I get 3 units? This coordinate is 4. This coordinate is 1. So 4 minus 1, you will get 3 units. Remember, we are only looking at the y coordinate here. Okay? We're only looking at the y coordinate here. Then, now, oh, sorry. Now looking at the x coordinate. So this is minus 2. This is 2. So your xb is equals to 4 units. Okay, so now let's get started. Your sine ABC, sine ABC should be equals to sine ABC equals to 180 degrees minus, sorry, sine 180 degrees minus angle ABC. This is the trigo identity. 180 minus angle ABC is equals to sine ABX. Sine angle ABX. And if you calculate this, it is your opposite, which is 3 over AB. So again, you have to use your coordinate geometry knowledge to calculate AB, or you can also use your Pythagoras theorem. So given that AX is equals to 3 units and XB equals to 4 units, your AB is basically equals to square root of 3 square plus 4 square. So this equals to 5. So once you have all this, it's just equals to 3 over 5. Okay. Then your next part, your cos ABC equals to negative cos 180 degrees minus ABC equals to negative cos angle ABX. Okay. So if you see, my working is actually very structured. So I do want you to write down all this so that your thinking is very structured. Okay. So your negative cos ABX, if it's just cos ABX, it would be 4 over AB, which is 5 units. So it's negative 4 over 5. Okay, so the first two parts is okay. Then now your part C. Tangent ACB. So they want you to find the tangent of this angle. So in this case, I would look at this triangle, okay? I will look at the combination of these two triangle. So this whole angle, okay, let me draw in red. This whole angle is actually, sorry, this whole length XC is equals to 6 units plus 2 units. So it's equals to 8 units. Okay. So again, just simple identities. Your part C, tangent angle ACB is equals to opposite, which is 3 over adjacent 8 units. Okay, simple. Okay, so again, before we carry on, your AB, you can either use this or you can use coordinate geometry. So if you use coordinate geometry, you would get -2 -2 square plus 4 -1 square. So you again -4 square plus 3 square, 16 plus 9 square root, and you get 5. Okay. So this is just to show that you can use either Pythagoras theorem or coordinate geometry. Okay, now we'll take a quick break before we move on to the next video.